these, what kinds of arithmetic we're going to look at here. So we've got Metro Healthcare, and we'll go through the for-profit example just because it's easier to start that way, and then we can relax the assumptions for not-for-profit. It's going to acquire a new X-ray machine. It has a 4-year lease, includes some maintenance. So what kind of lease is it? Operating lease. It meets IRS guidelines, and the rental payment would be $280,000 at the beginning of each year. So you would have to make the first payment the day the machine is delivered to the organization. On the other hand, Metro can buy the asset. It will cost $1 million, and the bank will charge them 10% interest, and they would have to pay for their own maintenance, which would be $20,000 a year, again, at the beginning of each year. At the end of the 4 years, they would be able to sell the machine for $100,000. And we'll just assume that their tax rate is 40%, and therefore the equipment has a 3-year maker's life because it's going to last 4 years. And remember, makers is spread over 1 year, 3-year asset is spread over 4 years. So here are the net cash flows from owning the asset. And let's just go through each one so that we fully understand where they're coming from. What is the negative $1,000 in the top left-hand corner? The purchase price of the machine. So this is the after-tax cost of owning the machine. This is the first option. We're going to look at leasing in a minute, but here, let's just assume we're going to buy it. So the $1,000, negative $1,000 is the, this is rounded off to millions, is the purchase price of the asset. Now the next line is the depreciation tax shield. And I claim that the depreciation tax shield in year 1 is $132,000. So what is that number and how did I get it?
The percentages with the makers.
Mm-hmm. So what did you do? What do you do with? You're right.
The percentages that are allowed for the 4-year span.
Okay, so I tell you the maker's percentage for this is, in the first year is 33%. So walk us through the arithmetic. How did I get to 132?
So you take the 33% and you multiply that by the price, and then you multiply, that would be $330,000 times the tax rate.
That is the correct answer. So what he did is he took the $1 million purchase price, and makers allows the organization to deduct in the first year 33% of the purchase price. So 33% times $1 million is $333,000. They pay tax at 40%, so in fact by purchasing this asset, the depreciation tax shield will be then at $333,000 times the tax rate of 40%. It's a positive number. Why is that?
Tax deductibles.
Right. The tax bill that this organization faces will be $132,000 less by buying this asset. That's why it's a positive inflow. You've reduced your tax bill by $132,000 because you purchased an X-ray machine, of which $333,000 is tax deductible in the first year. So what's the 180 in the second year?
What's the percentage for the second one?
Good question. 45%.
It's the same.
It's the same thing.
Yeah.
It's going to be the $1 million times the 45% times 40% of that amount. And so you keep going across the row until the last year is $28,000 because it's 7%. So the depreciation tax shield is what will be is a cash inflow to the taxable healthcare organization that's decided to lease an asset. Let's go to the next line. Maintenance. It's negative 20 all across. Why is that? What is that number?
They have to pay $20,000 each year for their own maintenance.
Exactly. So because this is their owning, they're borrowing and buying this asset. They have to have they have to pay for maintenance themselves, and we were told that they'd have to pay the contract up front. So you can see that there's $20,000 starting in year 0, because the day you start operating the machine, that's the day that the equipment maintenance company will want their money for the next year. So you can see there's negative $20,000 at the beginning of each of the 3 years. And then the 4th year, there's no cash outflow, because the cash outflow in year 3 covers the maintenance from that point to the end of the life of the asset. What's the next row? Tax savings. 40% of the maintenance cost, because the $20,000 a year is tax deductible. There'll be an $8,000 reduction in the taxes that are owed by this organization. So again, a reduction in the taxes is a cash inflow. And then finally, the residual value is 100. What does that mean? At the end of the life of the asset, they can go to the market and they can sell the machine for $100,000. And what's the RV tax?
Gain on the sale.
Exactly. We're told that this asset lasts 4 years. It's in the 3-year makers class. It lasts 4 years. And at the end of the 4 years, what does the IRS say it should be worth?
$60,000.
If you add up the 132, if you add up all the depreciation that's claimed on this asset over those 4 years, what would it add up to? It's a 3-year asset, so makers goes over 4 years, and this is a 4-year cash flow analysis. At the end of the 4 years, what will the asset be worth from the IRS perspective?
Nothing.
Nothing. It's been fully depreciated. But the problem tells you that, in fact, they could sell the asset for $100,000. That represents what? A capital gain. Because you're selling it for more than the IRS says it is worth. You would then have to pay tax of $40,000 on that capital gain. That's the final cash flow in the bottom right hand. So you add all those cash flows up, and those are the net cash flows from owning the asset. Are there any questions about this arithmetic in terms of how we got there?
Residual value. Use that term as
The RV means residual value, or the disposal value, or there's different words for it. So, what do we do with that? Well, we're going to now compare that to leasing. So, Metro's 10% cost of debt is the appropriate discount rate, but it's a tax-paying organization, so we have to discount those cash flows using the after-tax cost of debt. So what we're doing is we're taking the cash flows that we just identified there, the negative 1012 and so on, and we're going to discount all those cash flows by the after-tax cost of debt, which is 6%. And if we do that, we get a negative 639,267. Okay, so in this example, because leasing and debt payments are a pure cost, there are no revenues, so to speak, we're going to want to compare the cost of leasing versus the cost of debt. And whichever has the lower financing cost is the one we want to go with. So if we discount those cash flows by 1 minus the tax rate times the cost of debt, we get a negative 639,267. That is the present value of the cost of owning the asset over the 4 years. So now we're going to compare that to the after-tax cost of leasing. Because we can borrow and buy, or we can lease the asset. We've been told that leasing payment is $280,000 a year, due at the beginning of the year. And there's tax savings of 112, which is calculated by how?
Multiply 280 by 4%.
Right, so you multiply the 280 times 40%, which is the tax rate, and you get net cash flows of negative $168,000 per year. If you discount those cash flows by the same 6%, 1 minus tax rate times 10%, which is 6%, you get a negative 617,066. So now we've got two present values of costs. And all we have to do now is compare them. We calculate the present value of the cost of leasing is negative 617. The present value of the cost of owning is negative 639. The difference between those two numbers is $22,000. Should we lease or buy?
Lease.
We should lease. Leasing has the lower present value of cost compared to borrowing and buying. Sarah?
George, just one more time. I know that discounting number you had was 6%, which is 1 minus the 40% times the 10%. Where's that 10% number from again? Is that just given in a problem?
Where do I have it? There.
Okay,
Bank loan
so
rate
you
is
just take that
10%.
loan rate that they provide you with and use that. Okay.
And we're using the bank loan rate to discount the leasing cash flows. And the reason we're doing that is because of this principle that we just talked about right there. Leasing as a substitute for debt financing. So if you're doing one, you're doing the other. If you're doing the other, you're doing one. So we're going to take the leasing cash flows and we're going to discount them by 1 minus the after-tax cost of debt. Not 1 minus. We're going to discount them by the after-tax cost of debt. Amy?
On the slide 11, where did you apply that 6% to at the bottom to get the present value?
Took those cash flows
previous.
and discounted them by 6%. So and here I'm taking the leasing cash flows and discounting them by the 6% as well. So you're using the same discount rate on both the after-tax borrowing cash flows and the after-tax leasing cash flows. And essentially then all we're doing is comparing those two numbers to calculate the present value of the cost of leasing compared to the present value of the cost of borrowing and buying. So basically, the net advantage to leasing measures the dollar advantage of leasing versus borrowing and buying. So a positive net advantage to leasing means that leasing is preferable, and a negative NAL indicates that borrowing is preferable. So that's one way that we can analyze the lease. There is an alternative way, and the first way sounds very much like what kind of technique that we've used before.
NPV.
Yeah, it's really calculating the present value of cost, which is the net present value of cost, except there's no revenues here. So the other approach we can use is IRR, which is to basically calculate the internal rate of return of the different kinds of cash flows of both options, and then look at which one has got the lower internal rate of return of cost. Sorry, I have to wait for somebody. So what do we do? So I've got the leasing cash flows there. We've already calculated all those numbers. Those are the net cash flows from leasing. Those are the net cash flows from borrowing and buying. We take the difference between those two numbers, and we discount those numbers, and we find that the IRR, so you just highlight those numbers, the 844 over the negative 88, use the IRR formula, it will come out with 4.6%. So what do we do with that number? What does that tell you? That is the after-tax cost, percentage cost of leasing. What do you compare that to?
Cost of capital.
6%.
Julian's got it.
No.
It's the risk of leasing.
You're right.
The cost of capital.
Which is?
The after-tax cost of the loan.
Right, you're both on the same page. It's the after-tax cost of the loan. This is the after-tax cost of the lease, 4.6%. You can compare it to the 6%, which is the after-tax cost of the loan. So what happens when you compare those two numbers?
This is low.
The lease is lower, has a lower percentage cost than does the borrowing. So you get exactly the same decision. NPV and IRR will always give you the same decision. It's just that you get to the decision by a different route. So essentially, what we're saying here is the IRR of the incremental cash flow stream is 4.6%. It's less than 6%. So again, leasing is the better decision. And we just said, why is this true? Because NPV and IRR always give you the same decision. Okay, so that's the basic leasing model. That's the basic mathematics that we're going through to analyze a lease. Are there any questions at this point or comments at this point?